Okay, and our next speaker is Viacheslav Shvetsov, and he's going to talk about testing. Why so serious? Please applause.
Hi everyone, my name is Viacheslav Shvetsov, and today I'll be talking about testing with the help of doubles, saying more exactly about stubs and mocks. Usually when you're talking to someone and offer to use mocks, people do not always share your optimism. So my mission here is to share my thoughts at once to most people, to share my thoughts about doubles for as many people at once as I can. I'm not an expert on this, I just share my thoughts, my vision, and how it works in our team. During my report, I will guide you through some terms and meanings to understand that you all understand what I am talking about. In our company, we don't use acceptance tests. Ruby developers deal with APIs, so we use just only service tests and unit tests. So, have anyone heard about sociable tests and solitary tests? Distinction about? Okay. Who never heard about this will now. This and this is all unit test. Here, this brown square wrapped in the green dotted line is called system under test or subject under test. And these two brown squares are just how it's called collaborators, which are just internal implementation of this SAT. So, what differs these two meanings? Sociable test and solitary test. Actually, who prefers sociable tests will deal with real objects as collaborators. But when you choose solitary tests, you instead of these real objects, you will use fake objects. It's not even just distinction between these classifications. Martin Fowler separated this into two schools, actually, classic school and mocky school. Sometimes you could see that classic school is called London school, no, Detroit school, and mocky school is called London. Yeah. But for me, I think that is more suitable in this case to distinguish these meanings by Gryffindor and Slytherin, because we all have claims to each other, and we use magic in our test systems. But we, who will today say in favor of mocky school, we use dark magic. Oh. I won't make detailed review why people dislike doubles, because actually just misunderstanding or misusing this powerful technology. But I will show you what rules you must consider to not face these problems. And I think that would be enough. But isn't that, I will just show you some briefly explanations. If something or following will apply in your code, you just need to know that you need to keep a close eye on it. So, problem number one, duplicating implementation. What does it mean? Well, we have some service object searcher. We just receive some user by some attributes. First name, it doesn't matter really. To cover it by test, we just need to define this expectation, which will intercept this method call with these parameters, and you really don't have to do like this. It's really one good example of misusing mocks. Further, I will explain why. So, next problem is leading to a brittle test. By the way, it is service object from the previous slide, and if you will look more detail, you will see that this produced the same behavior, but we replaced this find by where expression and first. But leading to a brittle test, what does it mean actually? We replaced that find by this behavior by this expression where that produces the same behavior, but now our spec wants to intercept this this method call find by with these parameters, and now our tests are broken. Even that, we have the same behavior. So you don't have to do like this. It's really bad design. Problem number 3, nested mocking. We have repaired this tests. Tests. For that, we used this hard logic. We define some expectation for this method call with these params, which return this double, which expect for this. And this is hard to accept as a part of your code. Really, it's hard to read and understand. Okay, these are problems. Rules. So we can now review what are rules for doubles. Okay, mock role, not object. You don't have to mock a concrete collaborator because it might change, but the role will be the same. So SAT just need to know what role collaborator plays. What does it mean? Actually, we have some payment system. We are not interested in what it do, actually, the main process, but we are interested in this expression, push or notify. So to cover this service object by test, we need to define this expectation to exactly this class, pusher, to receive this method. It's really not so flexible, because if you want to replace this notifier system in some moments, you will need to replace this, of course, in production code and duplicate this what you replaced in this test. And it's really ugly. Not ugly, but not so flexible. How we can solve this in a good way? If you look, now we have passed notifier here, and we are not bound to concrete class. We could just pass some objects. We know nothing about it, except that it provides the role to notify, that it must provide notify method. This is how exactly looks tell don't ask principle in real life, and it's good practice. So, how could you see that this mocking technology not only could bring us to not only give us some avoiding some hard processing, but could lead us to some better architecture, to some more flexible. Because now we are Now we can pass what we want. Notifier, it could be some mailer system, or it could be even some WebSockets connection, and we could notify about anything. So, second rule, Mulk API you own. What does it mean exactly? Actually, mostly all developers who know this rule don't clearly understand this point. But what does it mean? It doesn't mean that external API you use in some moment will replace its expected behavior. But how we actually go with TDD testing? First, we write a test that would fail. Then we write some functionality that will suit for this test. And after that, we refactor it. And even we will replace some implementation of this, test will pass it. In ideal world, when we have our system not bound to some external API, we have, for example, this pusher notify expression, and if we want in some moment to change its internal implementation, we would make it in appropriate class. We wouldn't change something there, and this expectation won't be broken. But it is with our custom API. And according to external API, what would be? I've already showed you, but I will once more. We had find by, which we replaced by where expression, which do the same, but now our expectations are broken, and we must replace this expectation. Only mock peers, not internals. We don't need to stop all the internal logic, because it could be just and an implementation detail. It's more about how we do this scenario instead of what we do by it. Actually, as it's mentioned here, I couldn't generate some simple scenario, but I really sure that if you won't need this scenario, you will understand what I'm talking about, so we will skip it. Last point, but not least, why are they slow instead? What calls are slow? You should to think, do I have any influence on this part of functionality? Maybe it's a place for redesign and decoupling by roles before you will use mocks. If you don't have answers on these questions, you should not mock, because it will lead you to some problems, poor design, for example. So to sum it up, we have 4 rules. Mock roles, not objects. Mock your own API. Mock peers, not internals. Why is this slow rather than what method calls are slow? Know how considering the rules. Okay. Regarding the last point, I mean this, I think that almost all interactions with DB is redundant, and I will explain why. But we need to, but I need to show you it's on some simple example, which would be just show action. Okay, what would be business logic for this action? It's pretty simple. We need to find some user and return it. How we would write test for some standard way? If we choose the standard way, we will define some attributes. We will create some user. And in exercise phase of test, we will make this processing. And on verify phase, we would check this, assert on this state of this test. So I will show you it on a graph. We have, as I mentioned, we have 4 phases of test: setup, where we create our fixtures. In this example, we create user with some attributes. Exercise, where we would execute this, our test is only 2 expressions. On the verify phase, we would assert on some state or message, and we'll tear down, which is handled by our spec. We'll release some memory or flush in DB. So how it will be handled? On the setup phase, we create this user, and we need to pass this user ID to our SAT. And after that, active record find will return this user. I think that doing by this, we predefined our algorithm to only one scenario where this external API would just return this user. It wouldn't go by another scenario according to how find might work. And if it's so deterministic, why wouldn't we use stub here? Maybe, but I think we must check it how it will pass our rules. Okay, Mulk roles, not objects. It's really bad that we must do more concretely to our user, but according to that fact that user is just adapted to a primary source, a data source, I think it would be it doesn't matter, because in cases like where we use some simple find expression, we wouldn't change its implementation to something like Elasticsearch. But we will definitely use something like this in some where searches if we want to something harder than just simple find. So in this case, where we use just some simple find, this is passes. Mock your own API. As I said earlier, we have user just as adapter for our primary data source, and for case like find, we wouldn't change this implementation really. But when we have some complex SQL queries like where clause, we definitely in some future will replace this functionality, or maybe we'll just have some more additional requirements or some conditional requirements, something like includes, joins, or just replace this by Elasticsearch. So in our simple scenario where we use find, it's okay. Mock peers not internals. Well, in scenario where we use in our scenario, database is really external source, so we don't. So this point passes because it's not internal implementation. Okay, last point. Why is this slow rather than what method calls are slow? I think that we don't have to do. We don't have to do some data flow where we don't have some influence on it as a part of our algorithm, because it's really just responsibility of your adapters and databases. And I think that it is a good place for stub or mock. And perfect candidates for this would be just find methods, update methods, save and destroy. Why these methods? Actually, because they don't delegate their role and their internal implementation with outside walls. In comparison, where you use where clause, you could pass with calling this method some row SQL, and we couldn't be sure that this expression would work even if we stub it. So, one moment. Okay. You would think about how we could be definitely sure that this external API, even it's external, how we could definitely sure that it will be working like we expect from it. And I have a great plan, really. If you look exactly how this find method, update, save, destroy works, you will see that they repeat the same behavior. They do the same from test to test, and you definitely don't need to include this in each test. You could just test it just once with the real data and then be sure that you have some warranty that everything works like you expect from it. So, how will be now looking our implementation with stubbing? Here we used instance double, which is really a killer feature from respect free. We even could verify existing attributes if our model doesn't have them now. The test won't pass. And we could just define this expectation, which respect will intercept this call and return this user. So it will produce the same behavior, this test, and it will pass, but we won't use useless data flow. Another case for destroy, we have some service object user destroyer, which simply destroys user. How we will do this by standard scenario? We just define these attributes and creating this user. And on verifying phase, we just expect that user will be destroyed. We'll look once again how it will be executed. Once again, on the setup phase, we will create this user with these attributes. We'll pull to database. On exercise phase, we'll just execute this expression. And I think, back again, I think that from this method call, we don't have any control how it will be handled. I mean, destroy. According to tell don't ask principle, we could just assert that this method was called, and that's enough, I think. So, how it will pass according to the rules? Mock roles, not objects. Well, actually, we are not bound to some class. We are passing some objects, but in this case, it doesn't matter, actually. According to another points, the answers will be the same as in the previous example. And this is how this test for this service object will looks like. So we have this double class user attributes once again, and we are defining that we are asserting to receive this method call. So. Why not classic testing? If we accept the classic way of how we solve testing, we must accept that sometimes, or most likely, tests will be slow. In addition, you have to double this time, actually, because mostly you have predefined CI, which you must to be sure that tests will pass, and you will have to sit and wait. No. One moment. Of course, the way of mocking is not a silver bullet, and with it you can easily mess it up. But you should definitely do something with the speed of your test if you are not ready to sum it up, because tests should to prove you that you do everything right. If you are annoyed by them and you are trying to avoid them, you are not using them correctly. So, not the speed of test is your main goal, but the comfort to use them. Actually, if Ruby allows me in some future test, I expect the speed of tests I expect from it, I will return to classic way. Of course, it's really more flexible to debug with real data, not the mocks or doubles. But today I must accept the reality that with mockist way, I have almost 4,000 tests which pass in 1 minute. 1 minute, really. 4,000 of tests on my local machine, on local notebook. And with, instead of maybe, I don't know, 15 minutes by classic way. And the second, test your algorithm, not flow of data, which must be handled by some external sources. You must think that this is responsibility. This is not your responsibility. You should look some repeatable scenarios and think what you could do to avoid it. You are coder, exactly. Real problems of this style. Actually, I could mention only one problem. It's my personal opinion. It's nested mocking. It's really ugly, and it's more flexible to work with real data, not doubles that return doubles. And this nested expectation is really not so clear as a standard way. So, this are some additional sources. These rules came from this book. If you want to read it, this was written for Java, and you should definitely view this video and read these articles. It would be useful for you, even if you don't share my thoughts. Thanks.